Hello, and welcome to this video to accompany the AMSP Further Maths Conference Teaching Activities for Vectors session. In this first video, we're going to look at a classroom activity for introducing 3D vectors and the vector equation of a line. Now, this is a great activity to use with students. It's quite a physical activity. It involves the students standing up and pointing with their arms. So if you want to have a go at this activity now, if you want to stand up, you can try this for yourself. So the first thing to do is, with your right arm, point directly out in front of you, and this should make an x-axis. With your left arm, point directly out to the side to your left. This should make a y-axis. If you look down on your arms now, you should see a standard x-y axis with your arms at right angles to each other. If you now rotate your right arm so it's pointing directly upwards, you get a third axis, and this is our z-axis, and that also gives us the relative orientations of the x, y, z axes. And what we're going to do is get students to point in particular directions based on these being the x, y, and z axes. So in the first example, I'd show students how to point in the direction 3, 1, 1. To do this, you're going to point out 3 units, a fairly arbitrary choice of what 3 steps would be. So point forward with your right arm 3 steps, then move it a third of that, or 1 step, rotate it to the left, and then finally rotate it 1 step up. And you should be pointing just in front of you, just to the left a bit and up a bit. Similarly, we can try some other ones. 2, 0, 1, you would point 2 units out in front of you, not move your arm left or right, and then point your arm 1 unit down, and you should be pointing forward and slightly down. Finally, 2, negative 1, 4, you would point your arm 2 units in front of you, move it, swing it 1 unit to the right, and then 4 units up, and you should be pointing quite high up and slightly to the right. At this point, I would then tell students quite a bad mathematical joke, and I would ask them to put their hand up if they could point in the direction 0, 0, 3. If you want to have a go at that now, you might see where that's such a bad joke. But what I would want them to get onto mathematically is then thinking about how we could point in a couple of directions, one with the right arm and one with the left arm. So if you try this now, point in the direction 2, 3, 1 with your right arm, and in the direction negative 1, 1, negative 1 with your left arm. If you look, your arms should be at right angles to each other. It might need you to tilt a bit to see it, but this gives us a sense of what 2 vectors in 3 dimensions might look like when they're perpendicular. That's a great activity, gets students moving around, and it really gives them a physical way of thinking about 3D vectors. Where this then moves on to is trying to lead them into thinking about the vector equation of a line. So in this, you will need 3 volunteers in your classroom. You'll need 1 student to sit in a corner and make a set of axes with their arms. Better to have them sat down so they're slightly lower, I think, for this one, and ask them to point out in front of them for an x-axis, to their left for y-axis, and vertically up for a z-axis. And their right shoulder is going to give us the origin of our system, and the length of their arms is going to give us a unit. I would then get a piece of string and ask 2 other students to hold the piece of string in each of their both of them holding it in their right hand, holding it taut and making sure it's not parallel to any of the axes. And then each student's hand is going to be a point A for the first student's right hand and a point B for the second student's right hand. What this will allow us to do then is start asking some questions about points on the line that will get us to the vector equation of a line. I can then ask the question, what are the position vectors of the right hands of the students holding the string? So student A's right hand, in this example here, I'm going to say is at 1, 1, 2. And student B's right hand is at 4, 3, 0. My next question then is, what's the position vector of the point halfway between the two hands? Well, students should be able to work halfway between these 2 points and get the point with position vector 2.5, 2, 1. I'm going to ask them a series of questions. This particular peculiar example style of open questioning comes from the great ATM book Thinkers, which is really worth getting your hands on if you don't have it, but it's a way of getting students to progress their thinking towards a general case. So I asked them to give a particular point on the line. So can they give another point on the line? This is our idea of a particular. So the student might say, okay, I've done halfway along. What if I moved 2 lots of this gap from A to B? I would be down here somewhere, and that particular point would be at 7, 5, -2. Peculiar. The way I would ask this is to say to students, give me an example of another point on the line that you think nobody else in the room will have chosen. That's what I mean by peculiar, and it's a stepping stone towards generalizing, because they have to think, how could I construct one in a way that I don't think anyone else will construct the same one? So one thing I might do here is say, well, I could go 10 lots of the gap from A to B. I don't think anyone else will have chosen that, and that would give me my peculiar of 31, 21, -18. It's not massively important whether anyone else has got the same one. It's the act of trying to think of how can I construct a peculiar one helps the student think about generalizing, because to do this, they've had to think about, well, what is that gap from A to B? Well, that gap from A to B, or the vector that takes us from A to B here, is 3, 2, -2, and I can use any amount of that gap from A to get another point on the line, and that gives us our general point on the line. I can even use my parameter lambda as we do in standard. So my general point on the line is going to be 1, 1, 2 plus some amount. Students might not use lambda when they first do it. It's fairly easy to change whatever their parameter is, plus lambda amounts of AB, which is 3, 2, -2. So it's a great pair of activities, and you can see here how gradually we've moved from thinking about 2 points on the line in a very physical example in the classroom through to the idea of how the general form of the vector equation of a line works.